Hi, this is Matt Whitmer at Birdie Precision, and welcome back to Networking 101. In our next video in the series, we'll be looking at network topologies. So unlike RS-45, what we're typically used to seeing in our older style of communications, where we were stuck to using something like daisy chaining topologies, where you're going in one controller and out that controller to the next, and so on and so on. With Ethernet, we have a few options for our topologies. We have the star topology, which is pretty typical, a line topology, depending on devices that you're using, and then a ring topology, which also is a little bit dependent on the type of device that we're using. So we'll take a look at each of these individually now. So the first option you have available to you is the star topology. This is the typical topology that you'll see in an Ethernet network. It's what you're probably using right now to connect your laptop to your network at the office. And the pros that it has is it's super simple. You're running a single cable from your device to the switch. That's it. The cons are it has a single point of failure. If this switch dies, every device that's plugged into that switch is no longer on the network. No longer can see any of the other devices. And our second con is it's expensive. Not expensive in terms of hardware, but in terms of your cost to run all of the wire, because you're running home runs to every single device on the network. Our next option is line topology. The benefit of the line topologies is a shorter run, right? Your initial run from your switch is just going to go to that first device in the line, and then you're going to go to the next device and the next device. You're not running all the way back from each individual device back to the switch that you're trying to communicate to. And again, all of these devices are on the network and they can talk to each other. Problem with the line topology is that if you lose communication to any of these devices, or any of these devices loses power, any device downstream also loses connection to the network. So if we lost this device, it lost power, it died for whatever reason, the devices downstream would lose connectivity to the network as well. And then your other con is that it requires devices that have an onboard switch. Just because the device has two Ethernet ports on it doesn't necessarily mean that you'll be able to use it in this capacity. So something like a JS8000, it has two Ethernet ports on it, but those ports aren't routed to each other. So you can't go in with information from one port and come out the other port. A Honeywell Cyber 30, on the other hand, has an onboard switch, and all of those ports operate in the same way that a regular switch does. So you could take, any device in and go out to your devices downstream. And then building off of that line topology, you have something called a ring topology, which gives you one additional feature that the line topology does not have, and that is resiliency. So you still have the shorter runs that we were talking about before, but you gain this resiliency feature in that if I lost this second controller in the line, my switch would be smart enough to know, hey, I have this other route of getting back to the devices downstream, and I can still talk to them. Now, obviously, this resiliency only works for one device going down. If you lost, say, we had an additional device down here, and you lost that one as well, you would lose communication to everything in between. Now, the issue with this is that it requires devices with onboard switches and support for ring protocol. So the Cyber 30 controllers use one ring protocol. JCI IP controllers use a different ring protocol. And like we mentioned before, just because a device has two different Ethernet ports on it doesn't necessarily mean that this ring topology will work for you. So those ring topologies that I mentioned earlier, there are two main ones. The first is RSTP, which is Rapid Spanning Tree Protocol. This is standard on a vast majority of managed switches that are out in the world. More likely than not, if you've gone onto a large commercial network in an office building or something, they're using it behind the scenes to give themselves a little bit of failover capabilities. And this is the technology that's included on the Honeywell Cyber 30 controller, as well as the Phoenix Contact ILC 2050BI JACE controller. Your other option, and this option is not quite as standard or maybe familiar to an IT guy that you may run into down the road. It's called Media Redundancy Protocol. The difference with Media Redundancy Protocol is it's a little bit quicker for failover recovery times than the Rapid Spanning Tree Protocol is, because it was built for the industrial space, where any fraction of a millisecond or any millisecond amount of downtime can cost you money. So they've gotten that down, so it's super, super fast. Now, the Rapid Spanning Tree Protocol is not by any means slow at recovering, but the Media Redundancy Protocol is just a little bit quicker. Now, this is what's used on the JCI IP controllers, as I mentioned before, but it also requires a switch with a specific license on the switch. So Johnson Controls recommends using a specific industrial Cisco switch to make this happen that has that license on it, and they have some configuration tools that make it simple to set up for you. But just keep in mind that a regular managed switch is most likely not going to be able to do this media redundancy protocol. And that does it for our layer 1 topics, all of our hardware and everything on the OSI model. And the next video, we're going to look at layer 2 in the OSI model, which is going to bring us to MAC addresses.